Alright, so yesterday we worked on getting a graph of slopes, and today we're going to kind of wrap all that up. So the graph of slopes is basically what you have is the graph of the derivative. So a derivative is a function, and there's different ways to write it, but a lot of people like to write it this way with a little prime symbol, f prime of x. That gives the slope of the curve at any x value. Alright, so I'm going to give you some notation. Some of these come from Newton, some of these come from Leibniz. So we can have the y prime and then f prime of x. Those come from Newton. And then Leibniz used fractions. So you can have dy over dx, that means derivative, df over dx, so the variables can change. And then we also have d over dx of something like that. That means take the derivative of whatever is in the parentheses. So those are your notations. All right, and then I've talked about this a little bit. Probably should have talked about it more, but hopefully it'll make more sense today. But a tangent line touches the curve at one point and shares the slope of the curve at that point. So let's just draw a little graph. I like to do that one. Okay, so let's say we have a point right here, and that point is at A, f of A. This is the graph of f. So a tangent line, I like to make my tangent line pink. The tangent line is going to come, and it's just going to touch it at that one point. Just scrape it. And it's going to have the exact same slope as the graph does at that point. So what we could say is that the slope of the tangent line is going to be the same as f prime of A. So that's the value of the graph of the derivative at A. Okay, so this is the tangent line. Now, finding the equation of the tangent line is something that we're going to do a lot. And so what we use is called point-slope form. And that's when you know a point on the line and you know the slope of the line. You can use point-slope form. And so it's going to be y minus f of A, which is the y part of the point, equals f prime of A, which is the slope, times x minus A. And A is the x part of the point. Alright, we're also going to find a normal line. So let's make it purple. So a normal line to a curve at a point is the line through that point and perpendicular to the tangent. Okay, so I'll try to draw a line through this point perpendicular to the other line. So that's pretty close to being perpendicular. Alright, and then for the normal line, because they're perpendicular, the slope is going to be the opposite reciprocal of the tangent line. Okay, so let's do some check for understanding. All right, so for number 1, we are going to let f of x equal 4x squared minus 5. We're going to find f prime of x using the definition of the derivative. So yesterday I had you practice some of these without telling you that it was the derivative you were finding. So we're going to do f prime of x. When we don't have a value for x, we have to use the one with h. So the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, so we have quite a bit of work to do. We're going to take x plus h and we're going to put it in for x. So we're going to square it and subtract 5 from it. And then from that, we're going to subtract the original function and divide by h. Okay, so hopefully we're getting pretty good at squaring binomials. Alright, so I'm going to come up here. So just remember, we're still finding f prime. We're finding the derivative using the limit definition. Alright, so I need to distribute the 4. Alright, and then I already have negative 5 plus 5. I know that's going to be 0. So I'm going to subtract the 4x squared. Alright, and then 4x squared minus 4x squared subtracts to 0. So then we have 8xh plus 4h squared over h. Alright, and then I know an h can cancel out. So then, once that h cancels out at the bottom, I can go ahead and put 0 in for my h. This is 8x plus 4 times 0. Or, finally, my derivative function is 8x. Okay, and then B asks, what does each point on the graph of f prime of x represent? And so each point represents the slope of f of x at that x value. You could also say the slope of the tangent line of f of x at that value too. Okay, number 2 is kind of an advanced question. So to do ones like number 2, and they always put these on the AP test, and we'll practice them when we start doing other things with the derivative too. But anyway, for you guys to answer this question, we need the 2 definitions of the derivative. One we just used. Now this one, they're actually putting values in. So we'll do the one with the A's. Okay. So when we look at this function, this is asking you the derivative. So we need to figure out what f of x is, like what that function is, and we need to figure out what a is. Okay, so the function, and this one, because you have the h minus 0, is definitely talking about definition 1. All right, so the function is this right here, the natural log. All right, and then x is where you had put in that a plus h. So in this case, a plus h is E plus H, so that means A is E. Alright, so it looks like the answer will be this. We're finding f prime of E, because E is what we're putting in for A, where f of x is the natural log of x. Okay, and then number 3, the line that is tangent to q of x at -2, 7 passes through 5, -1. What is q prime of 2? Now what this is another way of saying is, what is the slope of q of x? I do that a lot. I write g instead of q, sorry. Q of x at x equals -2. So that's just the slope formula. So q prime of -2 means use the slope formula, where I'm going to subtract the y's on the top, subtract the x's on the bottom. So it looks like we're going to get -8/7. Alright, so that's just a fancy way of asking you to find the slope of q at -2. When we know 2 points it goes through, we can find that slope. Okay, and number 4 is a long problem. So we're going to find the lines that are tangent and normal to the curve y equals x cubed at x equals 4. Okay. To do this, I need to talk to you guys about stuff that I really wish you would have learned before you got to calculus, but it just wasn't in the cards for us this year. So there's something called Pascal's triangle. And Pascal's triangle starts with a triangle made out of ones. Right? And the far ends of ones, or the outside ends are always ones. The outsides are always ones, sorry. The insides are found by adding the diagonal numbers. So I don't want to draw those lines there because they're confusing. So to get this middle one, I add 1 and 1 and get 2. And then the outside of the triangle is 1. Alright, and then I have an outside 1. To get the inside, I add those together and get 3. Add them together and get 3. The outside is 1. Alright, and then my outside's 1. I add and get 4. I add and get 6. I add and get 4. I add and get 1. So this Pascal's triangle gives you what's called the coefficients if you are going to raise a binomial to a power. Now this one we use all the time, because whenever you square something, I tell you square the first one, multiply them together and multiply by 2. That's where the 2 comes from. And then square the second one. Now there's a little bit more to it, but that's the shortcut that we always talk about. Now we can do that with cubing things as well. So to cube something, you go down to the next level of Pascal's triangle. The first coefficient is 1, but this time it's 1 and then the a is cubed. Alright, and then we have the 3. Now this is where it's trickier. So what happens with the a's, the power on the a is going to go down each time, and the power on the b is going to go up each time. So a cubed has to drop down to a squared. And then b didn't have a power, so we go to b to the first. Alright, and then our next term, we have the 3. The a drops down, the b goes up. Alright, and the next term is a 1. The a drops down to no a. The b jumps up to a cubed. Alright, so we need that to be able to do the next problem. Alright, so here we go. So to find the lines that are tangent, you need 2 things. To do a tangent, you need the point of tangency, or the POT, And you need the slope of tangency. The slope of the tangent, I should say. So to get the slope, we need the derivative. And to get the derivative, we use the limit. As h approaches 0, f of x plus h minus f of x over h. Alright, and then this particular one, f of x is the cubing function. So we need to take x plus h and cube it, and then subtract the original, and then divide it by h. Okay, so I'm going to use Pascal's triangle and the binomial expansion. So I'm going to cube x. And then remember that the next number we multiply by in Pascal's triangle is 3. And then the x power goes down, the h power goes up. Right? And then we have another 3. The x power goes down, the h power goes up. And then it's a 1, and then the x power is gone, the h power is a 3. And bring down the x cubed over h. Alright, x cubed minus x cubed subtracts away. Alright, and h can get canceled out of each of these, so that's a square. Alright, then we're ready to put in 0. So it's 3x squared plus 3x times 0 plus 0 squared. So our derivative is 3x squared. Now yesterday we figured that out using the graph of the slopes. Okay, so if I want to find the slope of the tangent line when x is 4, I'm going to take my derivative and I'm going to plug 4 in for x. So that's 3 times 16, which is 8. That's the slope of the tangent line, or the SOT. Goodness. Alright, the other thing I have to have is the point of tangency. And for that, I go to the original function. Whoa. So I go to y equals x cubed. And I'm going to put in 4. So that the y value is going to be 64. So my point of tangency, the x is 4, the y is 64. And I have everything I need for my point slope formula. Alright, so we wrote it up here. A lot of times this f of a lot of times is just called y1, and then the a is just called x1. So whatever, however you want to write it, we take y Alright, we're going to take y, subtract the y coordinate, equals the slope, which was 48, and then x, subtract the x coordinate. Boom, that's my tangent line. Don't do anything else to it. Leave it just like that. Alright, and then we have a normal line that we're also finding. And we've done all the work. It's still going to go through the point 464. The only difference is our slope is going to be the opposite. Whoa. Oh, sorry. The slope is going to be the opposite reciprocal. What is happening? The the opposite reciprocal, so negative 1/48. All right, again, leave it. I know it's ugly. It's fine. Just leave it. Perfect. All right. Now that's something we're going to get lots and lots of practice with. All right, and then this last one, we have a graph of f, and we want to draw the graph of dy over dx. And that just means to graph the slopes. All right, so if we look at this section right here, think about what the slope is of that line. So when I look at it, it goes up to right 4. So that's going to be a slope of 1/2. So everywhere between -4 and 0 on my slope graph, we are going to have a line. So 1, 2, 3. We are going to have a line at 1/2. All right, and then we are going to do little open circles because at the end points or the corner points, the slope doesn't exist. We'll talk more about that later, so don't panic. Okay, so then we look at this section right here. And when I look at that section, we're dropping 1, 2, 3, 4, and going right 1. So in that little section, my slope is -4. So between 0 and 1, I'm going to have a little line at -4. Okay, then this section right here, what's the slope of a horizontal line? It is 0. So between -2 and 4, between 1 and 4, I am going to have 1, 2, 3. I'm going to have a little horizontal line at 0 because that's what the slope is there. All right, and then finally, run out of colors. This section here, I go up 1, 2, 3, 4, and right 2. So that's going to be a slope of 2. All right, so between 4 and 6, I'm going to have a slope of 2, so I'll have a little horizontal line at 2. All right, so that is another way to graph slopes or graphing the derivative. All right, so your assignment. Alright, it's out of the book, and I did change it slightly to make it be what I wanted it to be. There's a lot of different things on here, so I'm going to give you all a couple of days to get this done. So I want you to do 16 through 20 even, and then on 26 and 28, I want you to just do the A part, and then I want you to go back and find the normal lines. Alright, and then I want you to do 39 through 42 and 49 through 52. Alright, and then I'm not going to check this until Thursday. So I'm giving you some extra time because it's super, super important that you guys get this done.